Howdy. Maybe some of you know that hmm, I was thinking about the Alps a lot recently, about glaciers and all these kind of things. And a few hours ago, there came out a video from the USGS about Mount Rainier, Lahars. And it's really interesting. Let's have a listen to them. Because I was thinking, since many, let's say, months, I have noticed this thing in the Alps and I was like really intrigued and I have found it all over the planet. And yeah, let's just have a listen. I will show you later what I meant.
USGS scientists studying Mount Rainier have long recognized that the greatest hazard posed by the volcano is from landslides that begin high on its slopes and transform into mud flows, or lahars, that travel great distances down river valleys. Lahars are rapidly moving flows of water, mud, and rock. They can move almost as fluidly as water, yet be as dense as wet concrete. Lahars can bury or carry away nearly everything in their paths and leave behind a layer of hard rocky sediment. Large lahars commonly accompany volcanic eruptions, but they can also develop from landslides that occur without eruptive activity or any warning, making it very important that people understand lahar behavior and hazards. USGS scientists and mathematicians teamed up to develop state-of-the-art computer simulations that show what happens when large landslides on Mount Rainier's western flank transform into lahars and descend into the Puyallup and Nisqually River valleys. The simulations show where and how far the lahars can go, when they arrive, and how deep the lahar would be. This simulation starts with a landslide in the Sunset Amphitheater area. The timer shows elapsed time after the landslide begins. The colors represent depths. Light yellow is less than 3 feet, dark red is more than 150 feet. In this scenario, 260 million cubic meters of rock and ice, a volume similar in size to the electron mudflow that occurred at Mount Rainier about 500 years ago, slides off the volcano. If the material is dense, hard rock, the landslide stabilizes before flowing very far. This is the low mobility scenario, and it never reaches communities downstream. But if the rock is weak and has a lot of clay, the landslide will transform into a highly mobile, swift-moving lahar. Part of the lahar flows south and enters the Nisqually River Valley, but most of it moves into the Puyallup River drainage. The lahar reaches the town of Ording in about 50 minutes. The lahar slows and spreads across the wide valley between the Puyallup and Carbon rivers. The shades of orange represent depths of 6 to 16 feet. Along the river corridors, it is much deeper. After passing through Ording, the lahar continues to the Sumner and Puyallup lowlands, arriving in 3 to 4 hours after the landslide begins. The lahar will slow and come to rest in 4 to 5 hours, but the deposit.
Okay, sorry for interrupting here, but I want to point one thing out. Wide River. So we are in the Alps, I guess. Yes. So now, if we zoom out and put north where it belongs, or where it belonged, I wanted to show you at least one spot, which got me thinking some time ago already. And I was writing, I don't know what's happening with that. But I noticed wide rivers. Which have their origin in the Alps. And you can follow them. In some regions, they are like really easily followable. because they just stick out of the landscape through their color. Why it doesn't work as I would like to. These seem to be rocks, and this seems to be all in all a quite steep landscape. Now it understood what I wanted. So again, we are in the Alps. And I think that we should take into consideration that it is possible that we would have this kind of Lahar type event also in the Alps. Because Lahars are about water and mud. And I was also now starting to think about clay, the origin of clay. What is clay? Maybe I have to dig into clay a bit while we just zoom around randomly in the Alps. And I wonder how much of this material, which is in a way brighter in color than other rocks, which are almost black, how much of them are created by these kind of Lahar, alpine Lahars. And if we talk about Lahars, if there would be one single Lahar in the Alps, it would tell us that there would be a volcano. So, question remains, is there any possibility that this kind of Lahar type of thing could happen in the Alps too? The evidence is there already. The white rivers. And all the springs and all the lakes we have. This is darker color. This might have been fused together by electricity. That's why it's dark. There wasn't that much water anymore available so high up, so it got burned. Let's have quickly a look at some glacier somewhere. This looks intriguing. But it's not a glacier, obviously. But maybe one of those water veins, or however you want to call it, which could cause this kind of Lahar type of event in the Alpine region. If there's just all of a sudden really much water pouring out of that thing. Let's see where we are. map style, everything, and also photos. There isn't too much. We are obviously in the middle of the Alps somewhere. And I have been wondering every time when I have been in the Alps about the difference in the colors what you have every now and then. For example, here, that's a good example. That's really, really bright. Those things stick out like a sore thumb. Yeah, that looks interesting. But anyway, it would be interesting to have this kind of hypothetical map of the Alps if there would be some Lahar or flash flood going on there somewhere from a mountain on the same scale as Mount Rainier is. It would be interesting to know.
It may remain liquefied for many more hours, and flooding may occur downstream. This next simulation starts with the collapse of the steep cliffs of the Tahoma Glacier headwall. The timer shows elapsed time after the landslide begins. The colors represent depths. Light yellow is less than 3 feet, dark red is more than 150 feet. In this scenario, 260 million cubic meters of rock and ice slides off the volcano. If it is mainly dense, hard rock, the landslide stabilizes before flowing very far. This is the low mobility scenario that never reaches communities downstream. But if the rock is rich in clay, the landslide will transform into a highly mobile, swift-moving lahar. The lahar that travels down the Puyallup River drainage will arrive in Ording in a little over 60 minutes. There, it slows and spreads out across the wide valley. After passing through Ording, the lahar continues to the Sumner and Puyallup lowlands. The lahar that travels down the Nisqually River drainage will arrive at the national park boundary in about 5 minutes and the community of Ashford in about 15 minutes. The lahar reaches the Alder Lake Reservoir in about 50 minutes. The lahar begins filling the upper end of Alder Lake. The sediment-rich lahar, which is the brown color, mixes with lake water, which is blue. The lahar doesn't generate a substantial wave. Instead, over the next 50 minutes, the lake level slowly rises. About an hour and a half after the landslide begins, water starts overtopping the Alder Lake Dam. The computer simulation ends 2 hours after the landslide begins and does not address what happens to the dam when water begins flowing over it or what might occur downstream of the dam.
Okay, so you see and heard the word Lahar quite many times for whatever reason. It's really interesting because if you go back to Google Earth and watch at these white rivers, they are actually quite big and quite long. There are many of those. So I just wonder, are these remnants of Lahars in the Alps? There is some also here where we had some recent earthquake activity. Where are we? We have to go over here. Treppia. This might be just also, like as they explain, this kind of sedimentary stuff coming down in springtime when everything is melting. But this somehow doesn't. I don't know. It's too big. And they are all over the place. And you need this kind of white material to get it white. You just cannot get random stuff carried down by the river and then it just gets white. No. There. Otherwise, every river would be white. So there is something really intriguing about the white rivers, about Mount Rainier, about Lahars, obviously. So let's see how this theme develops. Is there any geothermal activity anomaly in the Swiss, Austrian, Italian, French Alps, Jura Massif, or wherever Germany, France, Europe in general? Maybe the Romans have experienced something similar back in the days. Some fluctuations. And they were surprised. So let's be more wise than the Romans and try not to be at least too surprised if something like that happens. Thanks. Bye.